Hi everyone, if you want to revise the whole of integration, mastering with all the type of questions, you are in the right place. And this video series will help you to achieve that. Check it out. Hi everyone, this is our 8th video tutorial in the integrations video collections. In this tutorial, we are specifically looking for integration by substitution. Sometimes when you see a question, the question can be changed to a different format by different variable by make the integration simpler. That is the whole idea about this. So for an example, we are going to look one question and then we have 10 questions to carry on doing the same concept of making the question into a different format and see whether we can see a pattern we already studied in the first 7 tutorials. Let's look at the question number in the pattern 21 example. X with 2x plus 5 dx. This is our first question. So the first question is like this. And now in the notes it says, take the most complex expression as the u or different letter as you like. Change the question from x variable to a u variable. And the u variable is the substitution one. Make sure differentiate the dx to du as well, right? So differentiate the dx to du and change the entire question to du. So the integration gets simpler compared to the original question. Leave the final answer in your original format. Let's look at this question. I'm going to make u as my subject. So u, I'm going to take it as a most complex one as a 2x plus 5. Now, you can differentiate du by dx, which is 2, right? So now you can cross multiply and find out what is dx. Dx is equal to du divided by 2, right? So that is the u 2x plus 5's differentiation. We already done that differentiation. Now one more thing you need to do, make the x as a subject in the u formula. So that is u minus 5 divided by 2, which is x. That is another work you need to be prepare that one. Now coming back to the integration. In integration x, I am going to change it to u variable, u minus 5 divided by 2, and now times by square root of 2x plus 5 is going to be the u, and the dx can be written as du over 2. Now I'm going to be changing this question into a most familiar format which helps me to integrate quickly. So 1 over 4 integration. So u minus 5 times by u to the power half du. Now I'm going to expand the brackets. Integration of u to the power 1 times by half is u to the power 3 over 2 minus 5 u to the power half du. And that is the answer for the changing the variable from x variable to u variable. But this format now can be integrated, right? So now the answer is 1/4. You increase the power u 1 by 1, so 5 by 2 over 5 by 2 minus 5 u 3 by 2 divided by 3 by 2, right? And now we put the c at the end. Right now I simplify a little bit nicer. So 2 is going to be go up 2 over 20, which is 1 over 10 u to the power 5 over 2 minus 10 over 3 u to the power 3 over 2. So the final answer, you leave it in an x format, which is 1/10. What is u? u as in 2x plus 5 to the power 5 over 2 minus 10 over 3 2x plus 5 3 over 2, and of course there's a plus c is going to be there, and that is the answer, right? So you are changing one format to a different format, basically one variable to another variable, making the question simpler, then you can easily integrate. That is the whole purpose of the substitution, integration by substitution. That is first question done. So let's do the second question. Let me clear the board. So that is the second question we are going to try to attempt. So question number 2. So question number 2, now we are going to do it together. So integrating x plus 1 to the power cube dx. Now I'm going to make the u as a substitution, u as in x plus 1. Now you can differentiate du over dx is equal to 1. So du equal to dx. And now integration, x is u minus 1. You can make the x as a subject, u minus 1. Then this is u cube, and dx can be written as du. How easy is that? Now integration becomes simpler, u to the power 4 minus integration u cube. Both of them is du and du. Now integrate u to the power 5 over 5 minus u to the power 4 over 4 plus c. And now u to the power 5, which can be written as x plus 1 to the power 5 over 5 minus x plus 1 to the power 4 over 4 plus c. And now that is the answer for the question number 2, right? So final answer, you need to leave it in the x variable. So now we are moving on to the question number 3. So what is the heading today? The heading is integration by substitution. You are changing the question into a different format to making sure integration gets simpler. Right, now this is 4x plus 1 and dx, right? Now we can't use the, because of the square root at the bottom denominator, we can't use the reverse chain rule, right? Making sure we already got the reverse chain rule idea. So that is not going to be work here. So the answer is u equal my 4x plus 1, and you can differentiate du over dx. It's 4, and you make the dx as a subject, which is du over 4, right? And now integrating 8x, right? And now this one can be written as 4x plus 1. Half is going to be minus half dx, and that is the currently what we are going to have. So now x you can write from the substitution. So from the substitution you can write x as a u minus 1 over 4, right? That substitution you need that one 8 times u minus 1 divided by 4, and now this one u to the power minus half dx is going to be du over 4, right? And now this 4, this 8 cancels with 2, 2 and 4. Half is going to be outside the integration. Integration u to the power 1, expanding a bracket same time, u to the power 1 times by u to the power minus half, u to the power half minus u to the power minus half du, right? So everything is du, and now I'm going to be integrate. Half is going to be at the outside. If I integrate u to the power 3 over 2 over 3 over 2 and minus u to the power minus half add 1, which is half, and divided by half, and that is the answer, right? And now that is the answer you are going to be so now you change everything to x format. So that is going to be finally 1/3, right? So if I times by that one, so 2 cancel, 1/3 u as in 4x plus 1, 4x plus 1 to the power 3/2, and minus, and then half going up to, so then that is going to be 4x plus 1 to the power half, and half and 2 cancels off. So plus c, and that is the answer, right? Please make sure you understand the algebra, expression, expanding brackets, and all this GCSE knowledge you need to have, making sure you leave the answer in a good format. That is question number 3 done. And now we are moving on to question number 4. So question number 4, same format, you to get some more practice about this substitution, integrating x 3 plus 2x cube. Now we have some knowledge. Now we are going to do it very fast. So u as in 3 plus 2x, and du over dx is 2. And now you can make the du as a subject, which is dx as a subject, so dx is equal to du over 2, right? Leave that one. And now x as a subject, x is going to be u minus 3 over 2, right? So now integrating, x is what? U minus 3 over 2, and that is in one bracket, and times by u cube, dx is du over 2. So now 1/2, quarter outside, integrating u to the power 4 minus 3u cube du. Now we are going to be integrated straight away, 1/4, and u4 integration is u5 over 5, and minus 3 u to the power 4 over 4, right? And that's how to do the integration. If you want to simplify a little bit more, 1/20 of u5 minus 3 over 16 u4, and I'm replacing everything to x format, 1/20 of u as in 3 plus 2x to the power 5, and not minus actually, it is it is not plus, it is minus 3/16 of u as in 3 plus 2x to the power 4 plus c. That is the answer, right? So that question number 4 out of the way now. I hope you understand some sort of knowledge in the integration by substitution, so which makes it clear, and the integration is like a doable format, so it gets simpler format now, right? Let's do a trigonometric with a function with a substitution. Integration, question number 5 we are going to handle. Sine 2x over 1 plus cos x dx. Now, this one, we're trying to understand how the things work. Sine 2x, you can simplify to double angle formula, 2 sine x and cos x, and 1 plus cos x, again, you can, that is a trigonometric function, keep it as it is. Now, how can we do this question? So I'm going to make this integrating sine 2x as 2 sine x cos x, right? 2 sine x cos x, and then I leave the 1 plus cos x as a denominator, right? And now I'm going to take u as a 1 plus cos x, 1 plus cos x. So du over dx, what will happen? Differentiating cos x is minus sine x. Now what will happen? I'm going to make the dx as a subject, which is du over minus sine x, right? Now I'm going to change a little bit. Integration of 2 is outside, sine x times by cos x is we can write as a u minus 1, right? And now over 1 plus cos x as a u and times by dx as a du over minus sine x. Now that sine x cancel with sine x, right? Now if you do your maths properly, that minus go to outside. So keep the minus to outside, integrating u minus 1 over u, right? U minus 1 over u can be written as u over u minus 1 over u du. That even better. So minus 2 outside, integrating 1 minus u to the power minus 1 du. Now the answer is getting easier. Minus 2 outside, integration of 1 is just u, minus u to the power minus 1. You don't need to make it as a, you leave it as it is as a 1 over u, because we have a ready-made formula, ln u. So that is ln u plus c, right? Now I make everything to x format. So minus 2 u as in 1 plus cos x and minus ln as bracket 1 plus cos x. You can write a modular function, bracket close, and plus c. So that is the simplest way to do this integration. So I change the bottom one, 1 plus cos x, looks like a little bit complex. So make that as a u and work the way through as a du by dx and make the cos x. Cos x is what? U minus 1. So those kind of things, I use that in the substitution, and my question become very simpler format, and that is the final answer for question number 5. Let's do question number 6. Question number 6, integrating sine cube x and cos squared x dx. And in this question, they already given u as a cos x. So if it is given, we will take it. So du over dx is minus sine x. Minus sine x. So integrating sine 3x, right? I will keep the sine 3x as it is, right? Cos x, cos squared is u squared. Cos squared is u squared, and dx is going to be du over minus sine x. Does that make sense? So if I make the dx is here, is du over minus sine x, right? And that is the answer. Right now sine x and one of the sine is cancels off, and now I got integrating sine squared x and u squared, and there's a minus. I leave it the minus outside, don't want to think about that complex. So du. Now only problem I have, sine squared, I need to write that. So sine squared, we all know sine squared is 1 minus cos squared. So 1 minus cos squared is 1 minus u squared, right? So I'm going to rewrite that one minus outside of the integration, 1 minus u squared, that is for the sine squared, and then again another u squared du. Now I can expand the bracket and make it more simpler, u squared minus u4 du. And now I need to make sure I do the integration properly. U squared means u cube over 3 minus u5 over 5, right? So u cube over 3, u5 over 5, and that is the answer, right? Now you can expand that one, multiplying by minus, and get the answer and replace the u with cos x. So u minus time minus is plus, so u5 over 5, so cos x, cos 5x over 5, then minus cos cube x over 3 plus c. And that is the answer for the substitution. I hope you understand the tutorial. And these 6 questions will give a kind of a flavor to understand the substitution. So substitution means you substitute a function to make the integration simpler. I hope you understand. Please subscribe to our channel if you like the video, and we will look at that remaining integration formulas and methods in the next tutorial. Thank you.